I'm going to work through the practice quiz for the solve by factoring quiz. So here we go. For number one, now before we start, let's just run over a few basic things. Right, so here's a few basic things to review. In this quiz, you're going to have to make a decision whether you're factoring or solving. The instructions will tell you what to do. When you're factoring, you remember you cannot find the x value, so you have to leave the factors. That's your final answer, the factors. So there's not going to be any equal to sign in it. And if you do have a factor, like you take out a common factor, you have to carry that all the way through the problem and even have it at the end. Now, if it's a solve, you're going to find the value of x that make it true, and it's going to have an equal to sign. So if you have a common factor, you could actually divide that common factor out, because what you do to one side, you can do to the other. So if, say, you had a common factor of 2, you could divide both sides by 2, and that common factor goes away. Now, some common flow that we're going to use to factor these things is the first thing you're going to do is you're going to be able to, or you're going to see if you can factor out any common factors. Right? Once you've done that, then you're going to look at it and see if there's a middle term or an x term in the middle. If there's not, maybe it's a difference of squares, something like 25x squared minus 4, of which you can take the square root of the first number and the last number, get 5x minus 4, 5x plus 4. If there is an x term or a middle term, then you're going to have to use a different kind of factoring. You're going to have to make the decision of whether the a value, that's the number that's in front of the squared term, is a 1 or not. If it is a 1, you're just going to use a simple basic factoring technique. You're going to try to find two numbers that add together to give you the middle number, which in this case is a negative 7, and multiply to 12. That would be, in this case, a negative 4, x minus 4 times x minus 3. And if it's a factor, you're going to head and just leave it in factored form. Of course, if it was solved, you'd go ahead and you'd have something like where this would be equal to 0, so you'd say x is equal to 4, x is equal to 3, right? But you only do that if it says solve, right? And the other technique is if the a that's in front of the x squared is not a 1, like if it's a 9, and you factored everything out, you're going to have to use the AC middle technique. And just briefly to review that, what you're going to do is you're going to take a times c, that's 72 in this case, and the middle number is 22. So you're going to find two numbers that multiply to 72 and add to 22. Well, that's an 18 and a 4. So I'm going to put x's behind them, and then I'm going to pull out the 22x and replace it with 18x plus 4x, because that's what equals 22. And so then I'm going to group them. So if you see I've got 9x squared plus the 18x plus 4x plus 8, I divide it down the middle, and then I'll factor out the left side. So looking at 9x squared plus 18, I can take a 9x out of that, giving me x plus 2. I'm going to have the exact same factor over on the right when I divide it down the middle. And so I know I got to have x plus 2, so the only way that'll work is if I factor out a 4. So my factors are 9x plus 4 and x plus 2. Okay, so let's go ahead and work some of these. Okay, so for the first one, they're factoring. I'm going to have to leave the factors. So if I look at this, there's no x term, it's a difference of squares. So the square root of 9 is 3. The square root of x squared is x, minus the square root of 25 is 5. Then it would be 3x plus 5. Number 2, remember the first thing we do is we always try to factor out any common factors, and in this one there's going to be a 3. So if I take a 3 out, that'd be like dividing both of these things by 3, I'm going to get 25a squared minus 16. So in the part that has in the parentheses, I'm going to look to see if there's a middle term, and there's not. So I hope this is a difference of squares. Notice that I have a perfect square here. The a is a perfect square, and the 16 is a perfect square. So I do. So the square root of 25 is 5. The square root of a squared is a. The square root of 16 is 4. So I have 5a minus 4, 5a plus 4. do number 3. Okay, the first thing is to factor out a common factor. You can see that a 4 can come out of there. So if I factor out a 4, I would get 9v squared minus 4. Looking at what's left, there is no middle term. This is a difference of squares. So 4, the square root of 9 is 3, of v squared is v, minus the square root of 4, which is 2, times 3v plus 2. Moving to the next one. It has a middle term, so it will not be difference of squares. I check to see what the value of a is. The coefficient in front of r squared is 1, so I could use the basic factoring technique, looking for two numbers that add to 6, multiplied to a negative 7. So how about x plus 6, x minus 1. Those two add to 6 and multiply to negative 7. The next one, there is no middle term, no v term, so this is a difference of squares. We can factor out a 2. That would give me v squared minus 49. And that would be 2 times v minus 7, v plus 7. And the number 6, the last of the factoring, if I look at this, I can factor a 4 out of all the terms, giving me x squared minus 2x minus 3. So now with what's left, I'm looking for two numbers that multiply to negative 2. Add to negative 2, multiply to negative 3. Well, how about this? 4 times x minus 3 times x plus 1. That would multiply to negative 3 and add to a negative 2. So notice how I had to carry my 4 down because I'm factoring and I can't get rid of it. The next one, now we're solving. So when you solve, you have to have a 0 on one side and everything else on the other, because this is like setting y equal to 0. So subtracting 3v from both sides, I get v squared minus 3v. And of course I need to move the 10 over also, so I would subtract it. Alright, it's not a difference of squares because I have a middle term. It does not have an a value. The a value is equal to 1, so this is going to be easy factoring. Two numbers which add together to give me a negative 3 and multiply to a negative 10. v minus 5, v plus 2 equal to 0. So I need to find the values of v that make each of these parentheses go to 0. Here it would be v is equal to 5. Here v is a negative 2. And number 8, once again, I have to get everything to one side so that I have a 0. a squared minus 10a plus 24 is equal to 0. So I'm looking for two numbers that add together to give me a negative 10 and multiply together to give me a negative 24. Since this is a positive number, I'm going to have two negatives because the middle number is negative. So how about a minus 6? a minus 4, that's equal to 0, so a is equal to 6, a is equal to 4. Okay, move all the terms to one side. For number 9, I would have 8n squared minus 18 equal to 0. Now I can factor a 2 out of this, so I'm going to go ahead and factor 2 times 4n squared minus 9 equal to 0. Now since it's a equal to, I could actually divide both sides by 2 and get rid of the 2. So I have 4n squared minus 9 equal to 0. This is a difference of squares over here, so that would be 2n minus 3 times 2n plus 3 equal to 0. Now I'm looking for the values of n that make each of these parentheses go to 0. So I could set up a little equation, 2n minus 3, that whole thing must be equal to 0. 2n would be equal to 3, n would be equal to 3 halves. Over here, I'd have 2n is equal to a negative 3, n is equal to a negative 3 halves. So my solutions are n is equal to 3 halves, and n is equal to a negative 3 halves. Okay, let's move the v over so that I have a 0 on one side. 2v squared plus v minus 3 equal to 0. Now, this does have a middle term, and the number that's in front of the v squared is not 1, so I'll have to use AC middle on this. AC is equal to a negative 6. The middle term is equal to 1. So two numbers that multiply to negative 6 and add to 1. That's going to be a 3, and a minus 2. So I'm going to put my x's there. And I can see that I need to put the negative 2 would probably be best. Those aren't x's or v's. The 2 would probably be better by the 2. So I'm going to rewrite my equation as 2v squared minus 2v plus 3v minus 3 is equal to 0. All right, grouping it, I would have 2v times v minus 1. Now over here, I'm also going to have v minus 1. The question is, what do I pull out of there to get me v minus 1? Well, that would be plus 3. So my factors are 2v plus 3. V minus 1 is equal to 0. So let's go ahead and figure out what makes those factors go to 0. For this side, it'd be v is equal to 1. Over here, I'd have 2v plus 3 equal to 0. 2v is equal to 3. V is equal to a minus 3 halves. Okay, moving on. Number 11, let's move all the terms over. So I would minus v squared from both sides. That would give me 8v squared plus 16v, and now I would add 6 to both sides, and I'd get plus 6. So I can take a factor out of this, and it looks like I can take a 2. So I would say 2 times 4v squared plus 8v plus 3 equal to 0. Now, if I divide both sides by 2, the 2 is just going to go away, giving me a little less clutter. Okay, so that's a problem I need to solve. So I'm going to have to use AC middle because it has a middle term, and the A value is 4. So I'm going to say AC, and I need to multiply to that, is 12, and the middle term is 8. So two numbers that add to 8 multiply to 12. How about a 6 and a 2? So 6v and 2v. So I'm going to pull out my 8v, plug in these two numbers, and I think I'm going to want the 2 with the 4. So let's go 4v squared plus 2v plus 6v plus 3 equal to 0. Splitting it in half, I've got 4v times, 2v, right? 2v times v plus 2. And over here, I'd have, that's still not right. Let me give it another shot. 2v plus 1. So if I pull out a 2 out of here, I get 2v. If I pull a 2v out of here, I get 1. So 2v plus 1. Over here, I'd have plus 3 times 2v plus 1. So I would have 2v plus 3 times 2v plus 1 is equal to 0. For here, I would have v, for this one here, I've got v is equal to a negative 3 halves. For this one here, I have v is equal to 1 half. For 12, I need to move the 18n over. 4n squared minus 18n plus 18 equal to 0. I'm going to divide out a 2. 2 times 2n squared minus 9n plus 9 equal to 0. So I can just get rid of the 2 by dividing both sides by that 2. So I'll have 2n squared minus 9n plus n 9 is equal to 0. Okay. Doing AC middle, I'm going to have AC is equal to 2 times 9, that's 18. The middle is equal to a negative 9. Two numbers that multiply to 18 and add to negative 9. How about a negative 6n and a negative 3n? So I'm going to put the 6 with the 2. So I'll have 2n squared minus 6n minus 3n plus 9 equal to 0. Splitting it down the middle, I would have 2n times n minus 3. Now notice that I need to have an n minus 3 over here, and since this is a plus sign in the equation and I need a factor of a negative 3, I'm going to have to factor a negative out of this so that the sign will flip. So that'll be a negative 3. And let's just check that. A negative 3 times n is a negative 3n. Negative 3 times a negative 3 is plus 9. So that matches with what I have. So I'll have 2n minus 3 times n minus 3 equal to 0. N is equal to 3 halves. N is equal to 3 for the second term. Next. Okay. I'm going to subtract 2 from both sides. That would give me w squared minus 4 equal to 0. That's a difference of squares. There is no middle term, so I would have w plus 2, w minus 2 equal to 0. W is equal to a negative 2. W is equal to a plus 2. For this one, there already is a 0 on one side. So what I'm going to do is factor something out. So I'm going to factor a negative x out. So a negative x. If I divide this by negative x, you can see that I'm going to get 2x left. If I divide this by a negative x, I'm going to get a negative over a negative is going to be plus 1. So the values of x that make this x go to 0 would be x equal to 0. The values of x that make this go to 0 would be x is equal to a negative 1/2. Okay, next one. Moving everything to one side, we have 5w squared minus 10w equal to 0, and you can see I can pull a 5w out of that. So if I pull a 5w out, I would get w minus 2 equal to 0. W is equal to 0. W is equal to 2. Next problem. Let's move everything to one side, subtracting w squared from both sides, or adding w squared to both sides. I'm going to get 16 w squared. Now I'm going to take this 4 and subtract it from both sides, so I get minus 36 equal to 0. Okay, I can factor a 4 out of that, so 4 times 4w squared minus 9 equal to 0, and then I could divide the 4 right out of it because there's an equal to sign, so I get divided by 4. I would get 4w squared minus 9 is equal to 0. That's going to be a difference of squares. There's no middle term, so the square root of 4 is 2w minus 3. 2w plus 3 equal to 0. So the values of w that make this parentheses go to 0 would be 3 halves. And over here, w would be equal to a negative 3 halves. Last two. Okay, for this one, I am going to subtract 32 from both sides, so I will have 0 is equal to a negative 2d squared plus 20d minus 32. Now I don't like to have this negative in front of here, so I'm going to go ahead and factor a negative 2 out. I would like what's on my d squared to always be positive, so if I factor a negative 2 out, I'm going to get 0 is equal to a negative 2 times d squared minus 10d, and then this sign would change to plus 16. Now I can get rid of the negative 2 because there's an equal to sign. Divide both sides by negative 2. So I get 0 is equal to d squared minus 10d plus 16. Notice that the term in front of the d squared is a 1. So I can just use easy factoring. This is not a difference of squares because I have this d term in the center. So let's go ahead and come up with two numbers that add to a negative 10 and multiply to 16. So that would be 0 is equal to d minus 8, d minus 2. So d would be equal to 8, d would be equal to 2. Last one. Negative 2x squared minus 9x plus 18 equal to 0. Now I'm going to go ahead and factor a negative 1 out because I don't like to have a negative on my x squared term. So that would be a negative 1 times x squared, and that would flip every sign, plus 9x minus 18 equal to 0. And then I can go ahead and divide both sides by negative 1 just to get rid of the negative 1. So what I'm really going to be solving is x squared plus 9x minus 18 is equal to 0. So I'm looking for two numbers that add together to give me 9 and multiply to negative 18. Actually, I lost my 2 there, so let me put the 2 back in the problem. So I have minus, that would be, I took out a negative 1, so this is still going to be a 2. I'll be at 2 there. Let me just rework it. It gets too confusing that way. Okay, so what I'm going to do is I'm going to factor out a negative 1 right here. So it's a negative 1. That would give me 2x squared plus 9x minus 18 equal to 0. Now I'm going to divide the negative 1 out of there. And what I'm actually solving is 2x squared plus 9x minus 18 equal to 0. Alright, so this will be AC middle. 2 times a negative 18, AC is equal to a negative 36, and the middle is 9. So I'm looking for two numbers that add to 9 and multiply to a negative 36. Sorry about that. I got interrupted. So what we're going to do is let's see, we needed two numbers that multiply to negative 36 and add to 9. So that would be 12 and a 3. So what we would have is a positive 12 and a negative 3. So I've got 12x and a negative 3x. Okay, I'm going to put the 12x with the 2. So I've got 2x squared plus 12x minus 3x minus 18 equal to 0. So down the middle, I'll split it down the middle, and what I'll have is 2x times x plus 6. Now I know I need to have an x plus 6 on this side. And notice that what the equation has is a minus, it becomes a plus, so I must have to factor out a negative. So I'm going to pull out a negative 3. And let's just check that. Negative 3 times x is a negative 3x. Negative 3 times 6 is a negative 18. So my factors are 2x minus 3 times x plus 6 equal to 0. So x is equal to 3 halves. X is a negative 6.